So once the MATLAB is installed in your machine, you can click on the menu link and start the MATLAB. So you might have a desktop shortcut, or you can start MATLAB from the command window. So this is the default view of the MATLAB window. What you are able to see here is the options on the top, a command window in the center, the current folder in the left side, and workspace in the bottom left. So here, what you see on the top side, these are the options to configure the MATLAB environment. So here you can actually make a new file. It may be a new script file or a model file. You can make a new folder, or you can find something in the file. You can import the data. You can save your workspace. You can analyze and run your code. And here is a Simulink button. So we are going to actually use this Simulink block for our further analysis. Let me click on the Simulink block and let's see how does the first screen of the Simulink looks like. So when you click on the Simulink block, it will come up with a Simulink start page. So once the Simulink start page is going to pop up, you will see some options on the left side where you can open any Simulink model which is pre-built. You can make any projects, or you can start learning as well from this side. Now the new file has so many options so that you can create a new model, or you can create a subsystem which is part of a bigger model, or you can create a library files as well. We are going to see all these options as and when it is required. If you scroll through this, you will be able to see many block set and toolboxes where ready-made templates are available. What is a template? A template is nothing but a basic file where you can start your modeling. So a template is going to be pre-built, and you can actually use this template. Let's say, for example, you want to start with the hydraulic system, and if I create a hydraulic Simscape model, then a basic template or a blank template will open up, and which is responsible for helping you to create a hydraulic model. So here you will see many other options, and while this is creating the model or a template, this is how it looks like. So here you have some fundamental input blocks, some conversion blocks, and some display. So there is a by default configuration, and this model is ready to run, and here you can have all Simscape Foundation hydraulic resources available at your fingertips. So this is called a template. It's a blank one, but you get some minimum inputs and outputs and configuration related to hydraulic kind of system modeling. So let's go through first a very blank model. So I'm going to create a blank model, and this blank model is this window. So now, for example, if you are new to this Simulink window, let me explain you all this part. So here what you see in this highlighted blue block is the simulation, how you can save your simulation, you can print, you can have a Simulink library browser. This is what we are going to explore in the very first look. And there are many options like debug, modeling, format, and apps. Apart from that, here you have an important window where you can have very related buttons to simulate your model. So once your simulation is built over here in the blank area, you can configure run, stop, and forward or step back. And there are other options of logic analyzer, data inspector, and other things as well. So what you see here is a blank model. And first of all, we may require to save this model in a typical file. So let me save this model and we'll name this as first model, right? So I'm going to name my file as first, and look at its extension. Look at its save as type. So these are Simulink models called SLX. Now there are another options where in the previous versions of MATLAB and Simulink, you can save your file as .mdl as well, and that is a model file. So these are the two extensions possible. Let's save our first file in first.slx format. So now my file is saved. I want to create a basic arrangement, or let's say a basic situation where we want to understand how does a Simulink work. So for that, how to add the blocks? So for adding the blocks, we need to have a look at the library browser. So this is the icon which represents the library browser. So if I click on the library browser, you will be able to see what are the all installed libraries available as Simulink. So this library browser is actually data set or pre-built models inside the Simulink environment. So we just have to drag and drop this models which are available in the library and connect them in our model. So if I show you how does a library browser look like, so what you see here in the left part is all different toolboxes and the block set. So what you see as a basic Simulink toolbox, the aerospace, and these are arranged in the alphabetical order, and you can see data acquisition, embedded coder, you can see the powertrain block set, sim events, Simscape, communication toolbox, etc. So right now we have opened the Simulink block set, and in that we have all these options which are again listed over here, right? If I click on the commonly used blocks, so here we have a commonly used block, let's say a bus creator, a bus selector, a constant, a product, a saturation, scope, sum, etc. Right? So these are very commonly used block, and I can simply drag and drop. Let's say, for example, we want to make a product, right? So in the earlier session, we know we have discussed that what is going to be a Simulink block diagram look like. A Simulink block diagram is nothing but all the equations in the form of the block or in the form of a graphical representation. So here, now you can see I have added a product block. So, and it shows X or the symbol of product in the middle. Now, what we need to do is we need to take two inputs and one output. So this is a block where it is going to take two inputs, one from this side, another from this, and there will be a third output, right? So these are the lines or signals which we are going to connect with. So what we need to do, let's have some constant numbers and do the product, and let's run the simulation and see the result. So basically it is as equal as you are writing a program for multiplication of two numbers. Now it's important to learn how we are doing this, right? So let me take two constants, and the moment I'm placing the constant in my model, it will ask me for what is the value of the constant, right? So let's say the value of the constant is 12.3, and I'm dragging it over here for a better connection. Now Simulink offers a very good way of connecting the signals where I need to click this. Now there are two arrows which are highlighted in the blue color. If I just highlight connect over this, it will be automatically connecting to this line. I can arrange the blocks and those lines will be arranged automatically as well. Now if I want to create another constant which is another input, I can just right click on this and make a copy of this. Now in order to change the value, I can change it from here itself. Let's say this is 4 and we can connect this to this line. So now we have two inputs ready to be multiplied. Now what this block represents, these are very simple thing, but how do we configure this block? So if you double click on this block, it will show you what is this, right? So it is going to explain you that what this block represents. It is going to output the constant specified by the constant value. It is also possible to represent this as one-dimensional vector array, right? So you can have multiple number of values assigned to this as well. You may provide signal attributes and what are the minimum and maximum values, which we will see later on. So right now, whatever I have entered 1, 2.3 or 12.3, that is assigned as a constant value. And if I change it from here, we can actually, the same will be reflected here as well. So these two are the constant blocks. Let's say, let's multiply with 3 instead of 4. So here you can see that it's changed to 3. This is a product block and this is a multiply or divide the inputs. So how we can use this block, that is explained over here, and what kind of multiplication you want. So you want element to element multiplication or you want a matrix multiplication, that you can check from here. Because right now we are doing a simulation with one constant number, it's going to be more simple. Now, how do we visualize the output, right? So let's say we are going to get some product output and we want to visualize the output. So another way of adding the blocks is directly double click over here anywhere in the model, and it is going to ask you, or it will be searching for the blocks, right? It is as equal as dragging and dropping the blocks from Simulink library browser. So instead of finding it in a library browser and there are so many other blocks, it may be better for you to quickly search out some display related block, right? So let's say we want to just display the output number. So I'm going to write display. So when I write display, there may be various types of display available. It may be Simulink dashboard display or a very simple display like this. Now this display is going to be let's say connected to this line, and when you have the line connections are easy and you can make it like this, you can just click on this part. All other possibilities of connecting this will be highlighted and you just need to hover your mouse to this block and the connection is made. Now what are the properties of the display, right? So the decimation point is 1 and you may keep it like a floating display or you may keep it unchecked, right? So if the input signal is going to be a string or there are many other data types which we are going to learn, then this will be displayed in a different way. So right now what is the format? It's short format, right? And if you have learned about the data types in the script or maybe any programming language, you know what is the meaning of short, long, bank, hex or binary or decimal, right? So let's keep it the default value short and let's run the simulation. In order to run the simulation, you have to use this panel and you can actually use all these blocks in order to configure your simulation time. So this one being the very simple one, MATLAB is not going to take much time in making a product of two numbers. Let's keep the simulation stop time as 2 seconds. Now if I press run, this will be displaying the output on display part, right? So this is the output which is available to us, and this is very simple model which we have created. You can actually create other different types of models as well. Now before you create a better model or maybe a fairly complex model, let's have a look at all the elements. What are the tools which a modeling engineer is equipped with in a Simulink environment? So if you go to the library browser, so we are going to now have a look at the library browser. So my screen is now showing the library browser, and here we have all different categories in the continuous category. So Simulink is a basic fundamental, and there are continuous, dashboard. So what is a dashboard? So dashboard is something like it looks like some lamp. It may be a knob, it may be a push button. So these are graphical user interface based GUI, right? So in a typical control room, when an engineer is sitting, they will be dealing with some kind of knob, some kind of gauge outputs, some kind of displays, some kind of rotary switch, right? Or maybe a toggle switch. So these are the dashboard related inputs. Now there are continuous block where you can use the integrator, where you can use a PID controller, you can assign a transfer function, you can have a delay signal, or you can do the derivative. And there are discrete blocks as well, which are nothing but representing the same blocks in a discrete environment. So remember, these are very fundamental blocks, and using this Simulink fundamental blocks only, there are many higher order or complex system blocks are created in all these toolboxes. So in order to work with a MATLAB, you need to be thorough with the fundamental mathematics of your problem. So whatever you are trying to solve, you must be knowing that, right? So if we, for example, see that let's say absolute value, right? So it's going to be a mode operator where even if you give some negative values, it is going to turn out into a positive value, its equivalent positive value. So here you have a complex to magnitude and angle. So you give a complex number here, let's say 3 plus 4i, and it will give you the real part and imaginary part, or the real value and the angle, right? So here these are many blocks. So here you can do the subtraction as well. Here you can take the sign of some number. Here is a product which we used recently, and there are many other blocks like a math function. So in fact, I can open some of the block here itself and understand what is the meaning of that. So it is going to take the exponent of the input, right? So mathematical functions including logarithmic, exponential and power, these are the functions which will be taken, right? Here it won't allow you to see what are the options, but when you add this block into your model, then you will be able to modify these blocks. So for example, if I want to add this, I can simply right click and add block to model first. So first is the file which we have just created and saved. So now this block is added. If I go to the first, now here we have a math function. Now if I double click, now I have possibility to choose which function we are using, right? So you can take a reciprocal, you can take a power or square. So whatever is the input, that its square will be given in the output. So whatever is the input, its exponent will be available in the output, right? This is as equal as writing a script where you have various mathematical functions, right? So instead of writing a script in a MATLAB environment or maybe other programming language, the block diagram is going to make your task easy, where you focus on creating the system level model and not the actual program. So let us see few more blocks where you have something related to sources, right? So here are the sources which we have used a constant value. Now instead of this, we can use the ramp as well. Now what is going to happen if we have a ramp input instead of a constant? So let's do it. So I'm going to use a ramp, and let's try to use ramp in our case. Now I have added this math function and I'm not going to use it. So I can select this and just make it disable, and that is possible by comment out. And it is also possible when you just do click on this 3 blue dots, and you can just like do the comment out. If you have not comment out and you are not using the block, the MATLAB compiler or the model translator is going to give you an error. Now, so instead of multiplying with the constant, so let me not use a constant, let me use a ramp input. So what is basically a ramp? It shows in a signal like this, its value is continuously increasing with the time. Now, what is the value increment, right? So let's say its slope is 1. So at every second, its value is going to keep on increasing by 1. So now if we do this, what we are going to have in the output is not a constant number, but we will have a multiple numbers, right? So at every second, its value is going to be updated internally, right? This is as equal as running a for loop and increasing a variable whenever every for loop is executed. So let me run the simulation for a slighter longer time duration, let's say 10 seconds. Now, what are the expected output? What we'll be able to see in the output? So at the end of the 10 second, whatever is a display, that will be updated here. So let me run this simulation and let's know what is the output. So why we get 123 in the output? Because we are running the simulation for 10 seconds, and at the end of 10 seconds, because the slope is 1, we are getting the value of this block as 10. So now this is just a display. Now instead of a display, let me see all these values on a scope. So in order to use a scope so that we can have a record of all the previous values as well, so I can connect the scope over here, and I need to see, instead of a display which is going to be updated at the end of the simulation, we want to see what has happened as a plot. So what I can do, I can just right click over this signal and connect over this line. So now I have connected the scope. Now if I double click on the scope, will it show the result? No, because we have just connected the scope and the simulation is not running, right? So I have double click on the scope. Here you see is nothing, because simulation was run previously, not after adding the scope. So any modifications you do, you have to make sure that you run a simulation and then view the results. So this is a very simple way of creating the first model, and it's always advisable that you save your models as well frequently. So whenever you click on the save, this model will be saved on the hard disk and the star arrow will disappear from its name. So if the star arrow still appears, which means that there are some unsaved changes. So now what kind of output we are going to have in the scope? So in the scope, our output is going to vary from 0 to 10 seconds. So if I click on the run, my simulation is finished now. And if I click on the scope, here is what you see in the output. So this yellow line indicates the output at each time duration. And this is nothing but 12.3 t, right? So whatever equation we have implemented is nothing but 12.3 t. So here I have created a very fundamental simulation of 12.3 t. So Simulink block help us to actually create some text file also, which is relevant to this model and which is not going to be executed. Like this block which is commented out, we can make some annotations as well. So if I double click anywhere, instead of searching any block, if I click on create annotation, it will ask me to type any text. So this model is for 12.3 t, right? And let's say our output is y, and y equals to 12.3 t. So this is what we want to define as description of our model, and this can be also changed to a fairly larger text, so that next time you open your model, you will be able to understand easily what this model is about. So you may have some help related stuff over here, or you may have some your assumptions here where you want to say that 12.3 t, and if instead of a ramp of 1 t, if I like have a 2 t, so I can write 12.3 times 2 times t, right? So here you created your very first model, and while you are learning, I will recommend that you will try yourself that how the Simulink works, and you try making simulation as well. So now let's go back to the Simulink library browser and understand what are the advanced level blocks. So we are going to straightforward focus on the electrical and mechanical systems, because there are so many other block set which are like aerospace, which are related to communication, which are related to instrumentation and control. So let's go to the Simscape, which is again an electrical and mechanical library. So let's visit some electrical components over here. So here you can see the electrical components. Here you have the connectors and references. So you have a ground connection, which is a reference point. Here you have an open circuit kind of a situation. Here you have a phase splitter. Then you have electromechanical stuff. So electromechanical is nothing but the motors, and you may have a very fundamental actuators as well, right? So here you may have different types of actuators which are solenoid. So let me add this to my block. Now my block is fairly simple, and we have added a solenoid over here, and what you see over here is not exactly the simple block, but you have some graphical images, and there are more than 2 inputs, right? So here you need to connect positive, here you need to connect negative, and these are R and C, which are the mechanical part of a solenoid. So if you are aware of how a solenoid works, basically you need to give some DC supply, and this DC supply is going to create a magnetic field, and this R and C will be showing some mechanical movement. So this is a solenoid block, and basically you can double click and configure this for your model. So now the models are fairly complex, and here you can read about the description. What is the magnetic force, what are the mechanical output, what is the spring constant, what is the damping, and how much is the stiffness. So once you have done all these things, you can actually play with a solenoid system in your model. So this is about one library, and you will be able to see many different asynchronous and brush type motors. This is a very simple DC motor, shunt motor, or a universal motor. Let's see some mechanical blocks. This is Simscape category, and here you can have another category called drive line. So in the drive line, you will have all the things related to automotive related things, and here you have multibody and fluid related systems. So here you can have hydraulics, body elements, let's say some constraints. These are a variable mass model, a solid cylinder, a file solid, or maybe an inertia block, or forces and torques, right? So here you have very advanced blocks like spring and damper force, right? Now, how do you learn about a basic element, right? So basically you can actually learn about any block from the help menu, right? So let me try a simple resistor for electrical systems. So a resistor is nothing but a component which follows the Ohm's law as per our discussion in the first part. So if I click on this, now my resistor is available as a model. Now I want to learn more about this, and I want to get some more help. I can insert a resistance value over here, and I want to take help on what is this resistance. So there is an excellent MATLAB documentation available in order to explain you how this model works. So this documentation will help you what are the fundamental governing equations which we have talked in the previous session. So those governing equations, in this case a linear resistor follows the Ohm's law, where voltage is equal to I times R. And what are the all behaviors? What are the other parameters? Let's say you want to implement a variable register. So here voltage is equal to I times R, and the R value can be updated by some external parameters, right? So let's say you want to implement a temperature dependent register, you may try using this one. And what are the ports? What are the parameters? They are all explained over here. So the MATLAB documentation, in this tab, you can see that there is Explore MATLAB, Explore Simulink. And if you click on Explore Simulink, you will be getting step-by-step process how you can get started, how you can do the modeling, what are the parameters of the simulation, how you can do the project management. So this is about the MATLAB help. And let's come back to our first diagram. And in fact, I can do the zoom in and zoom out by the scroll of a mouse. So let's say we have done a very fundamental equation in our first model, and we want to save this. And let's say if we do not want all these models, we can select them all and delete. And if we, let's say this is also of not use, you can keep it commented out or delete. So this is going to be a fairly simple environment where you drag and drop all your blocks and just hit the run. So this is about the introduction to the Simulink.